chairperson for this session for Waste to Wealth, Mr. Shekhar, participants, and of course the speakers. At the outset, let me thank the organizers for this Waste to Wealth Summit. This is Tri Summit, for giving me an invite, and thank you very much. I'll be talking about the innovation technologies for smart sustainable waste solution, especially for the non-ferrous sector, and that too, since the time was very short, I thought I'll speak more about the aluminium, what we have been working on. So before that, I'll introduce myself. I'm Anupam Agnihotri, Director, Aluminium Research Center, that is Jawaharlal Nehru Aluminium Research and Development and Design Center at Nagpur, which is an autonomous body under Ministry of Mines. And I'm a metallurgist by profession, and I spent more than 30 years in aluminium sector, so I call it my bread and butter. So thank you for being with us. So just make it full screen. All right. So I'll be talking about non-ferrous metal industries, how they are working to convert the waste to wealth. As all of you know that nowadays everything, all the activities are hovering around climate change. So from climate change we come to circular economy, we come to recycling, and the recycling has to play a very important role when it comes to the metal industry. As I was reading somewhere that all the efforts are to transit from linear to circular economy, and the whole world is doing that. And if we don't do it, say in another 10 to 12 years, so by 2050 the one earth won't suffice for the whole world. We'll require about 4 to 5 earth to suffice after 2050 for our needs. And they had done a very good calculation and shown that India will need in 2050 0.9 earth to meet its requirement, the way we are producing and consuming. So that's a lot of efforts on circular economy, and then when we talk about circular economy, of course, the waste to wealth comes into the picture. Next. So just to give you a glance about the non-ferrous metal industry, the global, and you can see when we talk about non-ferrous, aluminium has to play an important role, because when we talk about aluminium, we call it as a metal of a future. Because when you talk about lightweighting, aluminium has to play a very important role. When you talk about EVs, you talk about solar panel. So aluminium production is growing day by day. Not in India, as well as globally. What you can see in the presentation, the slide, from 2013 it has gone. This is the primary aluminium production. If we add secondary to it, it's about 25 to 30% of this, and that makes about around 90 million tons. And all other non-ferrous metals put together still won't reach that level. So I'll concentrate more on aluminium, because the production is more and there is more of a waste generation. They say when you produce 1 ton of aluminium, you produce about 3.5 to 4 tons of waste. So there is really something to worry about, to work about when we talk about waste to wealth. Next, please. This is the production of the 4 non-ferrous metals, what we have been working on in India. So for aluminium, it's about 4 million tons, then followed by zinc is 0.78, copper, then finally it's the lead. Lead, the beauty is like 80% of the lead is produced through recycling. So it's only 20% comes to the primary. So already it's meeting its circular economy mandate. And if you see the total waste generation, if you leave, majority is the overburden. That we can call it as a lean ore also. And there are a lot of works going on to beneficiate the lean ore, or to blend the lean ore with the high quality ore and get the solution for our overburdens. Now coming to the rest of the waste, if I talk about the aluminum industry, there is one spent pot lining, there is red mud and dross, and these are still challenges, and the whole world is working to find a solution to that, but economic solution is yet not out, commercial solution is not yet out, and people are looking for that. Similarly, copper, the overburden, since the ore is very lean, so we have a lot of overburden in that, and rest of the things are tailing, slag, anode slimes. For primary lead, already it is being recycled, but when we talk about the primary lead, the tailings produced are very high. It varies from 36 to 106 tons, and it does carry a lot of lead in that. And then coming to zinc, again the problems are tailing and xerosite. There has been solution for all the waste generated in the non-ferrous process industry. When we say waste, there are 3 E's associated with that. One is engineering, other is environment, and third is economics. And with our experience, what we feel and what we know, that 2 of the E's have been fulfilled, and the only setback to this solution or sustainable solution to the waste is the last E, that is economics. Next, please. So now, just to give you a brief about what exactly Ministry of Mines and Government of India is working to find a solution to the waste. There has been a draft policy for zero waste concept for primary as well as secondary. So the policies has been drafted and they are under consideration by Ministry of Mines and Ministry of Environment, Forest and Climate Change. So now people are thinking of having a kind of a mandatory policy for the waste to be treated. I'll give you an example of a red mud. Now there is a draft policy which talks about mandatory use of red mud in cement industry. If you see the kind of generation, of the red mud, that's a big issue. We produce about 4 million tons of aluminium and 6 million tons of alumina. Alumina is the raw material for producing aluminium, and 6 million tons of alumina. When we produce 6 million tons of alumina, that gives us 9 million tons of red mud. So we are producing about 9 million tons of red mud. But there is a solution. There is a solution. Aluminium industry can accommodate that red mud because it contains the raw material like Al2,3, SiO2, Fe2O3, which is a requirement for the cement industry. So people are talking about the mandatory use of red mud. Another is spent pot lining. There also, it's a good energy source. The spent pot lining has a GCP value of more than 5,000 kilocalories per kg. So that SPL, that is spent pot lining. Now we are talking about mandatory use of SPL in cement industry as well as the captive power plant, because every aluminum industry comes along with the captive power plant. There are talks about EPR. Very soon there will be EPR for the aluminum scrap, that is extended producer responsibility for the aluminum scrap, and that is how we look for the solution. We move towards the circular economy. Next, please. Now, already I've discussed there are three main solid waste from the direct waste from the aluminum industry, that is dross, spent pot lining and red mud. There is indirect, that is fly ash, because as you know, the energy smelters are, the aluminum smelters are energy guzzlers. So they are always associated with captive power plant, and the fly ash is an indirect waste from that industry. Other than that, we have carbon dioxide, and the carbon footprint of the primary aluminum is very high. It hovers around 15 to 20 kg per kg of aluminum produced. So that is the waste from the aluminum industry. Next, please. Now, sustainable options for aluminum waste utilization. Already, it's a proven concept. What I'm showing here, most of them we have worked at our institute. But the only problem, as I told you, is the economics. The overburden, yes, the raw material, it can serve as a raw material for construction and cement industry. The bauxite blending, it is a lean ore, it can be blended with the high quality, and of course the backfilling of the mines can be done with the overburden, and this has been proven up to a certain stage. Red mud, as I told you, cement is a good alternative for this. There can be a metal recovery. There is Al2O3 in that. It can go to the construction industry, as well as there are solutions as an absorbent for cleaning out the water. Soil amendment medium, there is a very good solution. We can add red mud to the soil. It acts as a catalyst and of course as a filler material for paint and pigments. So these are proven solutions for the waste, that is red mud. Then coming to the spent pot lining, yes, that can be a feedstock for captive power plants and cement industry. The first cut mainly contains the carbon part. 60%, 70% is the carbon part, so it goes to the CPPs and cement as an energy source. Second part of the SPL is mainly the refractories, so it can be used for brick manufacturing. We have given a solution to that. Ramming mass, raw material in steel making. Of course, it has quite good amount of Fe2O3. Fe2O3 is more than 50% in the spent pot lining. And then the mineral wool, it can be converted into the mineral wool also. Now coming to the dross is good, the metal is recovered, the alumina is recovered, and of course the salt which are used for the melting during the melting process can also be recovered. It is going to be a good source of our green hydrogen as well as ammonia. It can be converted into polyaluminum chloride for water cleaning, anode cover and bath making that can be reused in the aluminum smelter itself, a castable refractory because it has high amount of Al2O3, and a slag conditioner in steel making. So these are the sustainable options, kind of a proven sustainable options of the aluminum industry waste. Next please. Now, as I told you, the only thing which is missing is the economics, and to meet or the match that E, we have to have a smart management of the waste. So when we talk about this smart, of course, when we talk about Industry 4.0, there has to be a Waste 4.0 concept among the non-ferrous metal industry. So we talk about the Waste 4.0 or the smart red mud management. There can be AI for red mud generation. There can be a prediction for that based on the composition process methods of the ore. There can be forecast consumptions depending upon the composition of the red mud. Process optimization and control, how to control the hazardous material or the material which are not desirable or the material which higher cost of production of the aluminium can be reduced by using this. Then we have automated monitoring and reporting where sensor networks and IoT devices can be helped as to monitor the red mud ponds. They can also detect the pH, temperature and moisture levels, enabling the early detection in changes of the properties of the waste, and it can also automate reporting to the regulatory authorities, the kind of generation it does. Next please. Coming to the dross management and the smart spent pot lining management. Similarly, here also there can be the AI can be used to optimize the parameters which will minimize the production of the dross, sensors to monitor key process variables in real time when we're doing the melting, and then AI models can predict dross formations on historical process data. Neural network examples are there which can predict the amount of dross generated. Coming to the SPL, yes, we can based on the AI or the ML models, we can identify the chemical composition in advance and the potential usage of that. And all this will help in process deviations leading to decrease usage, production of SPL and more increased usage of the spent pot lining as an alternative to the energy source. Next please. The challenges amendment by smart waste utilization, the diverse composition, this has been an issue with the waste because there is a lot of variation in the composition. So no one size fits all solution for utilization. It has to be tailor-made. There, the smart solution, the AI ML can play a very important role. Technical expertise, which requires specialized technical knowledge, can be shared on various platforms to help abate the challenges of this waste. Economic viability, some methods may not be economically viable, but of course, when AI and ML comes into picture, this can become an economic viable solutions. We have to talk about the risk assessment when it comes to emission, leaching, and safety. Public perception has to be changed, and various social platforms have to be used to talk about the potential environment and health impacts on public while we are processing these waste. The lack of awareness, people have to make aware of the utilization of this waste and their benefits. Scale and consistency, achieving consistent water waste supply and processing, that is one of the issue which keeps is a challenge when it comes to the solution for the alternate industry. Logistic and transportation has to be made logically possible if the waste hazard needs to be utilized. Next, please. So I can conclude that AI ML modules and engagement of platforms and industrial can make economically possible to use this, to convert this waste into wealth. Then a culture of data-driven decision making by using AI analytics, it is only in industry, and there has to be a waste 4.0 solution for this. Then technology-driven solutions, it has to be tailor-made, specific characteristics for non-ferrous mineral industries because there is a lot of variation in the composition. Then encourage collaborations between academia, industries, and develop smart and sustainable waste utilization options. And last but not least is the government intervention for policies as well as a regulation for waste to wealth concept. Next, please. Thank you very much.